Academic graphing rational functions, part 1. Okay. So this stuff is a lot of new material. It's kind of a fire hose, but so it's gonna be a lot of new material today, but none of it is particularly challenging in my opinion. Okay. So we'll start down here. We'll skip those first two. Okay. Come down to these three. These. Okay. Ignore the points discontinuity stuff. Mrs. Halls gave me these notes. I kind of doctored them a little bit. Okay. So the first thing you do is always factor everything. First thing you do is always factor. Always factor. Okay, so we're going to factor this first one real quick. All right. What is the top factor to y? X. Good job. What is the bottom factor to y? Maybe a little shell, right? What are my signs? Plus and minus. So two factors of 6 whose difference is 1, that's 5 and 1, right? And once there be a minus left over, so we'll put the big factor next to the minus. Okay, cool. So we're all factored, okay? And then I put these letters here to give an order of what I want to find them in. So let's start by finding the wholes, okay? All right. Huh? Oh yeah, it would be. It'd be 6 and 1. It'd be 3 and 2. I'm so sorry. Hey, good job. Thank you. Sorry about that, guys. All the factoring problems just kind of blend together because I've been doing factoring problems all day, every day for the last 2 weeks. Okay. So it'd be what? 3 and 2. Thank you. Okay. All right, what are my excluded values here, first of all? What are my excluded values? So then, so my excluded value is going to be x equals -2 and x equals +3, right? And then these two, when we simplify, what happens? These cross out, right? Okay. So what you're called your wholes right here, we're first going to write down what our wholes are. Our wholes are going to be all the excluded values that cancel. All the excluded values that cancel. Okay? What would that be here? X equals -2, right? X equals -2, okay? The x plus 2 is the factor that cancel, but it corresponds, right? That corresponds to an excluded value of x equals -2. Okay? What do you think? And then VA. Anyone VA? VA stands for what? It stands for vertical asymptote. So I'm going to do this in another color. So I'm going to highlight that. I'm going to color code these notes for you guys. VA. Okay, vertical asymptote, that's what it means. That's what it stands for, okay? This is going to be a vertical line. Okay? It's a line that the actual graph, gets closer and closer and closer to forever, but never actually touches. Okay? What do you guys think the vertical asymptote is going to be? So the wholes were the excluded values that get canceled. What do you think the vertical asymptote is going to be? Yeah, it's going to be the excluded values that didn't cancel. So it's going to be x equals +3. Here it's going to be x equals +3. So we got our wholes. We have our vertical asymptote. Okay, the hole is going to be a point. It's going to be like a little circle we draw on the graph. It'll be like a little hollow circle. Okay, you guys saw that. You guys saw that in piecewise, right? It's going to look kind of like those little hollow circles from the piecewise graphs. Okay. But vertical asymptotes are going to be we're going to put them as like a vertical dashed line. So you're going to have some flashbacks to the piecewise graphing a little bit. Okay. C, domain. What's my domain going to be? You guys know this already. It's going to be, right, it's going to be all real numbers except my excluded values. So same thing as in 6.1. Okay, let's make sure we do that with our interval notation, okay? So what will that be here? It's going to be -∞ to -2, right? Union -2 to +3 union 3 to +infinity. Okay? Right, so it's just like, this is the exact same as in 6.1, okay? So how are we feeling about this, these first three? It's a lot of new information, but really, the only new thing we've done here is we've just classified our excluded values, right? All we've done so far is find the excluded values, write down the domain, and then the only additional thing we've done is just classify the excluded values into the ones that cancel, the holes, and the ones that don't cancel, the vertical asymptotes, okay? We following it so far? Yes?
The x left over on the top, what would that be?
You'll see that. You'll see later. Okay. You'll see actually right now. You'll see right now. Okay. So let's talk about the x-intercepts. So the x-intercepts are going to be points. It's going to be points. Okay. And what's the y-coordinate of an x-intercept? What is the y-coordinate of an x-intercept always? 0. Yep. So the y-coordinate is always 0. Y-coord always 0. Okay. To find the x-coordinates, I'm going to set the top equal to 0 and solve for x. Okay. So for finding the excluded values, right? Finding the excluded values, we've set the bottom equal to 0 and solve for x. For finding the x-intercept, we set the top equal to 0. So my top is just x. So I'm going to write x equals 0. Okay, that's my only x-intercept here is 0, 0. Okay. So you set the top equal to 0, and you solve for x, and then your x-intercepts are like your solutions, 0. Okay, does that make sense? Feel okay? It's not too bad. It's a lot of new information you guys need to remember, but if you know how to do it, it's not too bad. And then y-intercepts. You guys remember finding y-intercepts for lines? What was the x-coordinate of a y-intercept always? Yes, the y-intercept is going to be a point, okay? X-coordinate is always 0. Okay? How do we find x-coordinates, or sorry, how do we find y-intercepts of lines? What do we do? Plugged in what for x? 0, right? And we solve for y. Okay, so same thing here. You plug in 0 for x and solve for f of x. Okay, we want to write f of x is the same as y, right? We're trying to switch over to talking about f of x. It's the same thing though, okay? So what would and sometimes it's easier to go to the original function. You don't have to. So what would so I'm going to do plug in 0, so I'm going to find f of 0. That's going to be what here? It's going to be 0 squared, right, plus 2 times 0, all over 0 squared, minus 0, minus 6. I plugged in 0 for x, and I plugged that into the original function they gave me. Yeah, see that? And that's going to give me 0 over 6, which is 0. Okay? So that 0 right there, that's going to be my y-coordinate, right? That's going to be the y-coordinate. So what is my y-intercept as a point then? It's going to be 0, 0, right? All right, my x-coordinate right here of my y-intercept is always 0. And then I got the second 0 because I plugged in 0 to the original function. I got 0 out. Okay? All right, you guys following? And I'll talk about HA in gray down here. All right, can I move on? Okay, let's talk about HA. Okay, if VA stood for vertical asymptote, what do you think HA stands for? Yes, it stands for horizontal asymptote, but I actually like to call them end behavior asymptotes. EBAs, end behavior asymptotes. Okay. I like to call them end behavior asymptotes because, so a vertical asymptote, what did I tell you guys? It's a line that the graph gets really close to forever but never touches, right? An end behavior asymptote, all right, it's going to be a horizontal line that the graph gets really, really, really close to forever but never touches, except in the middle, near zero, in the middle of the graph, near zero, your graph can cross it in the middle. That's why I like to call them end behavior asymptotes, because it's really only an asymptote as you get like really far away from the origin. Okay, that's why I call them end behavior asymptotes, okay? To find these, we're going to look at the degree. So look at original function. Look at the original unfactored form. Okay? All right? And in particular, we're going to find the degree of the top and the degree of the bottom. Okay? Do you guys know what I mean by degree? We talked about it on the last test, right? What's the degree of a polynomial? It's going to be the highest exponent, right? So the top would have a degree of what? 2, and the bottom would have a degree of what? 2, yeah. Do you guys know what a lead coefficient is? It's going to be the coefficient of that highest degree term. And that's called a lead coefficient. It's the number next to the highest degree term, okay? So here's what we're going to do. Your end behavior asymptote is going to be y equals something. It's going to be a horizontal line, right? In our purposes here, it's going to be a horizontal line. Either next semester or next year, we'll find where it can be a diagonal line. But there's going to be 3 cases though, okay? You find the degree of the top, you find the degree of the bottom, okay? First case, if the degree of the bottom is greater than the degree of the top, our end behavior asymptote is just y equals 0, okay? Just got to remember that, okay? The degree of the bottom is greater than the degree of the top. The end behavior asymptote is y equals 0. Okay. Second case, if the degree of the bottom equals the degree of the top, then the end behavior asymptote is y equals lead coefficient of the top over the lead coefficient of the bottom. Okay. The third case, what's my third case going to be? If the degree of the bottom, yeah, if the degree of the bottom is less than the degree of the top, you're going to get what's called an oblique EDA. You're going to get, and we don't have the tools, we don't know enough yet in this class to find what the oblique end behavior asymptote will be. And this is another, but yeah, this is another reason I don't call them horizontal asymptotes. Does anyone know what oblique means? Diagonal, yeah. So you're going to need diagonal end behavior asymptote. That's another reason I don't call them horizontal asymptotes. Okay. We're not going to worry about this right now. Just note that it's oblique. Okay. I wouldn't expect you to find the oblique asymptote for me yet. I just want you to know, right? I just want you to know. Okay. What's the EBA here? If you find a rational function whose the degree of the top is greater than the degree of the bottom, I want you to be able to tell me that it's oblique, but not do anything else right now. Okay. Next semester we'll get into that. Okay. Okay. How are we feeling? So you just want to do it for this example? Hey, what's my degree of my top? What's my degree of my bottom? So which case here then does this fall into? Yeah, the second one, right? The degree of the bottom is greater than the degree of the top. So what's my end behavior asymptote? 1 over 1, right? So it's going to be, which is 1. Okay, so the 1 over 1 came from the lead coefficient of the top, which is 1, divided by the lead coefficient of the bottom, which is 1, okay? That's all the new info, okay? That's all the new information here. Yeah?
Can you go back to the steps?
What were you asking, why?
Is that an
top. That's a 1, sorry. Badly written 1. It's also a badly written 1. So it's y equals 1. Okay. All right, let's move on to that second one, okay? So someone find, we start with what? Factoring, okay? So the top is a difference of squares, okay? If you can't factor at this point, you're in hot water. The water you are in is hot. Okay? What are my excluded values going to be? Yeah. And does anything cancel here?
Wait, can you?
Nothing cancels here, right? Okay, nothing cancels here. So both of my excluded values are going to be what? They're going to both be holes or both be vertical asymptotes? They're both going to be vertical asymptotes. So it's going to be x equals 3 and x equals negative. And remember, these are vertical lines. That's why they're called vertical asymptotes. Okay, so then what are my holes going to be? Trick question, none. No holes here, sorry. What's my domain going to be? You guys should know this one. It's just like in 6.1. What's my domain? Let's make sure we're familiar with that interval notation. And then now we want to find those x-intercepts. How do I find an x-intercept? Set the top equal to 0, right? So what x values, and I'll use, what did I use over here? I'll use green. I'll use green again, okay? So we set the top equal to 0. What x values are going to solve that top equation? That numerator equals 0. It's just like what we've been doing for excluded values. So x equals negative 1, and x equals positive 1. Okay, so those are going to be my x-intercepts, but I want them as points, right? Okay. The y-coordinate of an x-intercept is always what? 0. So my two x-intercepts are negative 1 comma 0 and 1 comma 0. Okay. Y-intercept. Y-intercept. Okay. What is the x-coordinate of my y-intercept always? It's going to be 0 comma something. How do we find that something? You just plug in x equals 0. Yeah, you can plug in x equals 0. So we're going to do f of 0 equals, we can use either the factored form or the unfactored form. I like using the unfactored form. Negative 1 over negative 9, which is 1/9. So our y-intercept here is 0 comma 1/9. Calling them HAs, like calling them EDAs. It's my end behavior asymptote going to be here. It's going to be, why are you saying 2?
Number 1? No.
So, wait. Wait, sorry. Oh yeah, the case. Oh yeah, guys, good job, awesome. I was really confused. I thought you were telling me it's 2. No, so it's case 2, right? So what is it then here? What does it become? 1 over 1, right? Because when the 2 degrees are equal on top and bottom, we divide the lead coefficients. It's going to be y equals 1. Okay. End behavior asymptote. End behavior asymptote. It's an end behavior asymptote. Right? It's not always horizontal, and it's not always an asymptote near the middle, right? It only acts like an asymptote at the ends of the graph. Okay. How we feeling about this? It's new information, but it's not too difficult. Okay, now we're actually going to graph these. Okay. Now we're actually going to graph these. Okay. So let me write down some steps for you guys. And I'll color code these as well. What am I doing? Holes are pink. Holes are pink. Vertical asymptotes orange. Domain. We can just write the domain. I'm just going to write the domain. X-intercepts are green. Y-intercepts are blue. End behavior asymptotes. Can I start using red for the end behavior asymptote? Okay. So we're gonna, the steps here are plot your vertical asymptotes as dashed vertical lines. So it's going to be kind of like when we did piecewise. Okay, I want you to plot all your x-intercepts as points. Okay, I want you to plot your y-intercept as a point. And I want you to plot your end behavior asymptote as a dashed horizontal line. Okay, and then I'm just going to write this last step. Then you're going to plug into calculator and sketch. So what we get to do, so we're using our calculator to graph these, but we have to plot these things first because the calculator, like they'll show up in the calculator, but like they won't be like, trying to think of the best way to say this. They won't like explicitly, like these things like won't explicitly show up on the graph in your calculator, so you have to fill them in yourself. And then you can use the calculator to kind of like fill in. They look kind of weird. The graphs are going to look different from anything you've ever seen before. So there's a lot of like, there's like a bunch of Nike swooshes, and yeah, okay, we'll see. Picture's worth 1,000 words, right? Picture's worth 1,000 words. Okay. So let's find our hole. So first step on all these is what? Factor. Okay. So let's pull it a GCF in top. Otherwise, it's going to be really hard to factor. Let's pull it a GCF in the bottom. It's actually done. Factoring. Okay. Okay. There we go. There we go. Okay, so we factored. What are my what are my excluded values? Excluded values. That's the bottom equals 0. Don't get it mixed up. It's going to be +3 and 0. Is that what you said? Oh. Yeah, yep. So those are my excluded values. Does anything cancel here? Do any of my factors cancel? Okay, no. So what are my holes going to be? Nothing cancels, so what are my holes going to be? None, yeah, good job. But what will my vertical asymptotes be? Yeah, it'll be x equals 0 and x equals 3, right? What's my domain here? Everything but my holes and VAs, right? So it's going to be negative infinity, comma 0, union 0, comma 3, union. I'm going to go a little faster through that since we've already talked about it. Okay. Then deny, there we go, redemption. What are my intercepts going to be?
-1, +2.
Okay, but we want them as points.
So, -1, 0, and then 2, 0.
Good job. Yep, so she just set the top equal to 0. She set all these factors in the top equal to 0. Solve for x. Okay. y-intercepts. So the x-coordinate of my y-intercept is always what? 0. And how do I get that y-coordinate? Right, we plug in, we do f of 0, we find f of 0. That's the y-coordinate. That's going to be 2 times 0 squared minus 2 times 0 minus 4 all over 0 squared minus 3 times 0. Oh no, we got 4 over 0. What's going on there? What do you think the y-intercept is if we got undefined? It's not 0, it's just going to be none. Okay? And that makes sense, right? Where is there a vertical asymptote? X equals 0, right? Where do I graph the line x equals 0? Straight, it's the y-axis, right? Right? A vertical asymptote, right? The graph never touches my vertical asymptotes, right? So does my graph ever pass through this blue line here? Does it ever pass through the y-axis? No, so there's not going to be one. So that makes sense. So that makes sense. It's just none. Yeah. So no y-intercept. End behavior asymptote will be what? Who said y equals 2? Monica? Why are you thinking that? Yeah. Yeah. Absolutely, okay? So she looked at the degree of the top and the degree of the bottom. And again, it's a lot easier if you look at the original unfactored one, okay? The degree of the top and bottom are both 2, so they're equal, okay? So we find the horizontal asymptote by dividing the lead coefficients, 2 and 1, okay? All right? We feel okay about that? So now we're ready to start plotting stuff. So let me plot my vertical asymptotes as dashed vertical lines. Okay, so x equals 0 and x equals 3. This is why we had to talk a lot about how to plot, how to graph lines. Especially vertical and horizontal lines. Just to prepare you for this moment. Okay? Remember your training. Okay, let's plot my x-intercepts, -1, 0, and 2, 0. Okay, so those 2 points. Let's plot my y-intercept. Oh, there isn't one. Okay. And I'll plot my end behavior asymptote as a dashed horizontal line. That's y equals 2. Go. And my last step is what? Plug in and sketch. So we need to get our graphing calculators out. Okay. I'll show you guys how to plug this into your calculator. Okay. I'm going to use a paper packet. Yeah. We're on 22. Okay. So I'm going to go to my camera. Okay. You guys see all right? Okay. So here's my function. Okay. So let's put that in my calculator. I'm going to go to y. So first, I'm going to go to y equals. Okay. I'm going to figure that out. That's for calculus. Okay. So you're just going to do this like any other fraction, but make sure you put parentheses. So it's going to be a pair of parentheses divided by another pair of parentheses, okay? And then inside my top parentheses there, I'm going to put the numerator, so that 2x squared minus 2x minus 4. Inside the bottom, I'm going to put that denominator, x squared minus 3x, okay? So I'm going to do left parenthesis, and I'm going to put my numerator in there. So 2x squared minus 2x minus 4, and then close your parentheses. Okay. Then divided by, okay, left parenthesis, x squared minus 3x. Okay. All right. So let's all practice typing that in. I just put the numerator in parentheses, then divided by the denominator in parentheses. Yes. Yeah. Okay. Make sure we are able to type that in. You guys feel okay about that? And let's make sure my window's all right. So I'm going to hit zoom, and I'm going to select zoom standard. That'll give me the standard window. You guys see this? So to the left, so do you guys see like how where my two vertical asymptotes are? It doesn't explicitly show them, but those are going to be right here. There's three. You guys see how there's three parts of my graph? There's like an upside down Nike swoosh, and there's like a little like S thing, and then there's a right side up Nike swoosh. Okay. So to the left of our first vertical asymptote, we need to put an upside down Nike swoosh like that. So let me go to my first vertical asymptote. I'm going to graph this in dark blue. Okay. And I need to graph an upside down Nike swoosh that's bounded by my two asymptotes here, and I got to pass through that x-intercept. Okay. Got to pass through that x-intercept here. Okay. So I'll make it a bright green. All right. You guys see that? So I'm making an upside down Nike swoosh that fits in my little box there. Okay, it's below my end behavior asymptote to the left of my vertical asymptote. Okay. Let's look here in the middle. Okay. In the middle, I need to draw what? In between those two vertical asymptotes, I need to draw that little upside down S thingy. But I need to make sure I pass through that x-intercept. Okay. So guys, look. You can never ever touch one of my orange vertical asymptotes, but in the middle I can pass through my red horizontal, okay? That's why I call it an end behavior asymptote. Another reason. Okay? And again, make sure you pass through that x-intercept. Okay, and then we gotta look at that. We gotta graph that third part there, that right side up Nike swoosh. Where do you guys think I'm gonna put that? Yeah, so to the right of that second vertical asymptote. Okay, it's got to be to the right of that orange and then above the red. It's got to be. So I'm gonna do a right side up Nike swoosh in this little box right here. Okay. Feeling okay about that? Will Fletcher's feeling okay about it. Naomi is too. Good? Okay. Good. Okay. I guess boredom means we're not too panicky. That's good. Okay, so that's it. That's it. Okay, so you guys kind of see how I just filled in. You guys see now, like the calculator, the graph on the calculator is right, but it doesn't like very clearly show where all your asymptotes are and such. Yeah.
So the one, like the far right one, that just follows the orange.
Yeah, it's going to be boxed in between the orange and red.
Okay, and it doesn't touch them; it just like follows.
Gets
parallel.
really close. It tracks to them, gets really close, never touches.
Okay.
Yeah.
So as long as we draw them into the points and they don't actually touch the lines, we're good.
Yeah, and you have to have and make sure like it's on the right side of everything. Like
Okay.
if this were flipped over, I'd count it off.
Right.
Okay. Yeah. But yeah, and it can. Right, but the only time it can touch an asymptote is in the middle. It can touch the end behavior asymptote. See, I just went through. Jay, was your question?
I was going to ask the same thing.
Yeah. Yeah. That's why I call them end behavior asymptotes, because it can touch in the middle. So it's only at the end that they look like asymptotes.
Did you coin that name, or did?
End behavior asymptote?
Yeah,
No. I'd have to live in it was probably coined a long time ago. Yeah. Algebra is an Arabic word, so the Arabs did all this stuff a very long time ago, thousands of years ago. This math that you learn in high school is really old, except for calculus. Calculus is a little newer. That was in the 18th century, I think. No. When was Newton alive? 17th century? I'm terrible at history. All the algebra stuff has been around for, the quadratic formula is 5,000 years old. Yeah. Turns out if you don't have Netflix or electronics, the most fun thing to do is math. Anyway, can I move on? Sorry. I digress. Can I do 23? Let's do 23. Let's do another one. First step is what always? Factor. Okay. Shut up. Factor your equation.
On our test that this is gonna be on,
Yeah.
will you give us like this given here? Do we have to?
The directions will say. No, it's not quite like a
nine
list.
holes.
But yeah.
Okay.
Yeah. Mrs. Hollis's notes, she had like a bunch of problems, and like some of the problems were like only find 2 of those. I felt like the easiest way for us to learn was just do every single one every time. I'm sure like Mrs. Hollis's system works really well for her, but for me personally, I like to just do all of them every time.
So that's what you think we should do too?
Yeah.
Or do you think it would take too long?
The actual test questions will probably be more like just parts of this. But if we do all of them for every single problem, you'll know how to do it. Yeah. Okay. So there's my factored form, okay? So what are my holes going to be? So what are my excluded values? I'm sorry. What are my excluded values? Yeah. And does anything cancel here? So what are my holes going to be? None, but what will my VAs be? X equals 2 and x equals -3, yeah. Those are my vertical asymptotes, okay? My domain, I'm just going to whip through domains since we should know how to do it, okay? It's going to be everything but those excluded values. X-intercepts are going to be what? So when I solve for the top equals 0, I get what for x? Yep, and then my y coordinate for these is always what? So it's going to be -1, 0, and 1, 0. Okay. Okay. What's my y-intercept going to be? It's going to be 0 comma something. How do I find my something? You do f of 0. I'm going to use the original function for that. You guys can use whatever. I think it's easier with the original function. It's going to be, give me 1/2. 0 comma 1/2. Okay. What about my end behavior asymptotes? What's that going to be? Macy, it's going to be 3. Okay, good. And y equals 3 over 1. 3 over 1 equals 3. Okay.
How'd you get 1/2 to y?
So 0, the x coordinate's always 0. To find the y coordinate, I do f of 0. I plug in 0. I got 3 times 0 squared minus 3 over 0 squared plus 0 minus 6. You see that?
I forgot to plug it.
Okay. Yeah. That'll happen. All right. So let's do some graphing. Let's do some graphs. So let's do the vertical asymptotes. I'm going to do dashed orange line.
Should we always expect the asymptotes to be whole numbers?
No.
How did you get the EDA?
So what's the degree of the top and bottom? Are the degree of the top and bottom equal?
Oh.
Okay. Cool. Awesome. All right, let's plot my x-intercepts here. I'm going to use a little brighter shade of green. So -1, 0, and 1, 0. Good stuff. Okay, let's plot my y-intercept. 0 comma 1/2. You guys should know how to plot these points, okay? So I'm going to go through this a little fast, okay? And then my end behavior asymptote. Let's use a red dashed line. Y equals 3. Y equals 3, okay? Now we do what at this point? We plug into the calculator and we graph. Okay, so let's get rid of this old graph here. All right. So I'm going to do left parenthesis, and I'm going to do my numerator, 3x squared minus 3, close parenthesis. Then I'm going to do divided by, left parenthesis, put in my bottom, x squared plus x Minus 6. Make sure you do minus and not negative. There you go. Does that look like a sad face to you guys?
Yeah.
Yeah.
Just because it's good now.
So do we see how there's 3 parts here then? Nice. So to the left of our first vertical asymptote, we've got to put a right side up Nike swoosh, and it's going to be boxed in by those 2 asymptotes, by our red and orange lines.
Doesn't matter if just wants to not touch it.
Yeah. Like, make it look like that. Like, it doesn't need to be perfect, but yeah. And in the middle, I have what? Just a little like hump, right? So draw your little hump, but make sure it passes through those 3 points and then doesn't touch the vertical asymptote. Okay. All right, and then there's a right side up Nike swoosh on the right. It's got to be boxed in by these 2. Hey, you guys feel okay about that? For your homework, so you have the quiz tomorrow. Other than that, your only homework is I want you to do number 26 on your own. So do number 26 on your own for tomorrow so you can practice by yourself. And then other than that, study for the quiz with that quiz review, okay? I'm not going to collect it, but it's highly recommended. Hey guys, good work today.
Do we have to do number 1 and 2?
Just do 26. No, just do 26.